Okay, today we're going to continue what we started last time. Last time we started to talk about section 3 of chapter 22, the functional group of organic compounds. So we said that what is a functional group? We said functional group, just we remember, okay, what we explained last time. The functional group is just one atom or a group of atoms that carry certain properties and make the compound that contains this group has a certain behavior to make certain chemical reaction. So as the compounds which contain this functional group, they have the same way in the reaction, so they start to be categorized in certain groups. So like this, the organic compounds are classifying into classes or groups based on the functional group that they contain. And here, for example, this table represents to you, okay, that they have different organic compounds which have the same number of carbon. All of them, they just contain 4 carbons, but you could find that each one has different functional group than the other. So the first one here, butane, that represents the simplest, okay, formula, which is the simplest hydrocarbon, okay. Here just contain 4 carbons, okay, not the simplest ever, okay. So here this one, there is no functional group, just 4 carbons, they attach to each other by single covalent bond, okay. So let's compare this compound to the next. What the difference, guys? What the difference that you can observe between the first and the second? Guys, what the difference between the first compound and the second compound?
First compound has HO, the second compound has HO, first compound has H.
So actually that is the point here, okay? So we find the functional group that is the OH. So this hydrogen actually is replaced by a hydroxide group. So instead of hydrogen atom, we have a hydroxide group OH. So once this OH just found, this is a functional group. It causes a difference in the physical properties as you can see between these two compounds. Okay, so the melting point, the boiling point, and the density of the two compounds are completely different. That's just for this, okay, or the presence of this functional group. So this hydroxide group considered as a functional group causes change in the properties of the substance, and actually it make this compound react in completely different way than this one. Okay, so let's compare what the difference, okay, between this one and the first one, the third and the first.
عندها برضه HO والأكسجين has double bond with carbon.
Yep. Okay. So this is a functional group. So instead of CH3 here, okay, we have COOH. So it's an acid. Okay. This is a carboxyl group. Whatever the organic compound that contains COOH, that is, or it is an acid. And as you can see, also it leads to a great change in the physical properties and so on. So like this, that's represent functional group. It's just function group even could be one atom, as here, just one oxygen atom in the middle. Okay, that is a functional group also. So a functional group, as we can say, it can be an atom or a group of atoms that cause a change or that make the compound have a certain characteristics and have a certain way during the chemical, or they react in a certain manner. Okay, regarding to this, we could classify the different chemical compounds or different organic compounds into classes, okay, based on this. So here they are the classes of the organic compounds. So whatever any organic compound could be considered one of the following classes, okay, except hydrocarbons, of course, okay, they don't include functional group. So we have alcohols, alkyl halides, ether, aldehyde, ketones, amine, carboxylic acid or carboxylic acid, and esters. Okay, so what are difference? All of them, they just contain R. What's common is R. What are they are chain of carbons. Okay, they are the alkyl group. Do you remember the alkyl group like methyl, propyl, ethyl? Okay, they just a chain of carbon, whatever the number of carbon. This, okay, carbon, let's look at this chain of carbon, miss one hydrogen, in which this hydrogen will be replaced by one of this functional group. So what are the functional groups we have? So the alcohols have functional group OH, or the hydroxide. Alkyl halide, okay, they have the X, which is a halogen. Halogen are elements which found in group 17 in the periodic table, so it could be fluorine, chlorine, bromine, iodine. Okay, ether, they have the functional group, which is oxygen atom that is bonded by 2 signs by 2 different alkyl groups or similar alkyl groups. And aldehyde, they contain, okay, the CHO, okay, so they are carbon, okay, that have double bond with oxygen and one single bond with hydrogen, and we here the R is bonded to the bond which is still left. And the ketone, they have the function group CO, okay, and here amine that has the that's nitrogen atom with bonded by three bonds, okay, of different three R's, or maybe just one hydrogen, two hydrogen, and one R. So we're getting this detailed later, okay. So yesterday we explained alcohols, okay, already, and the alkyl halides, okay, especially the CFC or the chlorofluorocarbons, and we described their effect on the ozone layer, and also we explained the ethers, okay. So you put back to the video which I uploaded yesterday about this okay, different organic compounds. Today we're just going to continue talking about the other or the rest of the organic compound classes, which are aldehydes and ketones. So aldehydes and ketones, they have the carbonyl group. So what is the carbonyl group? It is CO, okay. So this is the functional group which is special about aldehydes and ketones. But still, what difference between aldehyde and ketone? So if you look here, that is the general formula of aldehyde, and that's the general formula of ketone. Who can tell me what the difference? Okay, who can tell me what? Please tell me.
Ketone doesn't have H and has R dash.
So good here, okay? So actually, we find that this is the carbonyl group. Both aldehydes and ketones, they have the functional group, but the difference, okay, or we call it aldehyde if the carbonyl group is attached by one hydrogen from a side and a carbon chain or alkyl group from the other side. That means this carbon will be bonded to a carbon from this side, another carbon, and hydrogen from that side. So in that case, we call it aldehyde. So the aldehyde must end by CHO. Okay, while the ketone, okay, we find the carbonyl group, okay, it's found, or the carbon here is bonded from the two sides by two alkyl groups. These two alkyl groups may be the same or maybe they are different, okay. So for example, I'm just gonna draw here, okay, I'm gonna say, look with me carefully here, guys. So what do you think, guys? This is ketone or aldehyde? This one.
Aldehyde.
I can't hear you. This ketone or aldehyde? Tell us.
Aldehyde.
Aldehyde. So why it's aldehyde?
Because it has carbon from its two sides.
So is it
اه
aldehyde? The aldehyde have
ketone sorry.
ketone, okay? So it's ketone because
آسف.
it's bonded by two carbons here. Actually, that is ethyl group, okay, C2H5, and that's here, okay, methyl group, so CH3. So it's bonded by two sides by carbons, okay, and the carbonyl group in the middle. So that is ketone. So simply in the
Sorry,
example,
الالدهيد is bonded by hydrogen
yes.
and
So let's take an
right?
example here, okay? For example, we're just gonna have here like this. So that is
Aldehyde.
aldehyde, okay. So because the carbonyl group, okay, it just bonded by one side by hydrogen and the other side by, okay, R or alkyl group, okay. So that's here the big difference, or that the difference between ketone and aldehyde, because actually in exam you may get a structure formula of compound and ask you to just mention what the class of this compound or this compound belong to which class. Is it alcohol, aldehyde, ketone, ether, okay, amine, or whatever it is, okay. So you're supposed to search for the functional group, and then you could detect which class it is here, guys. Okay, so always ketones and aldehyde, somehow people they just mix between them because both have the same functional group, which is the carbonyl. But okay, the difference is low. This carbon of carbonyl group, is it attached to two carbons or one carbon and the other one is hydrogen? If it's attached to one carbon and the other one is hydrogen, it's gonna be aldehyde. If two carbons, so it will be a ketone. Clear, guys? Is it clear?
Clearance.
Okay, so that's here. Okay, let's pass to the next, which is amines. So what are amines? So amines, okay, they are a category of organic compounds which considered to be a derivatives of ammonia. Okay, so what is ammonia? Ammonia is a gas that is made up of NH3. That means already the ammonia gas is NH3 like this, okay. So we consider, okay, the amines considered as a derivative of ammonia. If just one of these hydrogen is replaced by R, so instead of this hydrogen, we just put a chain of carbon alkyl group, okay. So like this, we get amine based on the number of the R groups, because here we have three hydrogen. So we may replace one hydrogen with one R, so that will be the simplest form of amine, okay. Then if we just replace two hydrogen, it could be replaced to, or even the 3 could be replaced by R. Okay, so that's we have 3 categories of amines. Okay, the primary, secondary, and tertiary. Okay, so based on how much R is bonded to the nitrogen group. Okay, so here like this. Okay, we said that amines are common in nature already, or they found in our daily life, or they found in nature, and actually they are the result which is from the breaking down of protein inside your body. So once you eat protein and you start to digest it, actually the wastes of protein are the ammonia that is going to be converted in your liver to be the urea that will be expelled out by your kidneys. Okay, so here also you find that because nitrogen, as we know, nitrogen here, the N it's 7, so the electron configuration is 1s, 2, then 2s, 2, and finally 2b. Okay, 2. So sorry, 3 here. Okay, so actually we find that in the outermost energy level, the second energy level, it contains 5 electrons, and because the orbital s and p, they are too close in their energy, so already here you could find that the nitrogen is already using the 3 electrons in the orbital p, or in the sub energy level b, to make the 3 bonds. Okay, here this R and this R. So they are 3 electrons sharing with this R. But still 2 electrons in the same energy level, okay, they are free. They are able to make extra bond, okay, or they are, you may, so in that case, okay, this unshared electron, or this unshared pair of electrons on the nitrogen, they are sometimes, okay, make them are base, or they are weak base. Why? Because once the amine dissolves in water, as you can see, here, it makes a kind of port and forming the that pull the hydrogen proton of the hydrogen of the water. Okay, get this one, and it releases the hydroxide group. Okay, which has the basic effect on the solution. So again, here, guys, this part is very important. We ask why amines considered to be bases. That means the amine they considered to be bases, not the opposite of the acids, or they may turn the red litmus paper into blue color. So why? Because we said that once amine dissolve in water, or once they mix the water, they are able to make a kind of bond by pulling the hydrogen proton of the water. Okay, by make sharing the unshared pair of electrons on the nitrogen atom of amine, and that will release, okay, some of the hydroxide ion free in the solution. This hydroxide ion has the effect of the base. Is it clear, guys? Is that clear, or you cannot understand this part?
Yes.
Are you sure, guys? Everyone, this part is clear? Okay. So then we're gonna pass to the next part, which is the carboxylic acid. So what are carboxylic acids? Actually, carboxylic acid, they are the organic compounds which contain the carboxyl group. What is the carboxyl group? Actually, the COOH, that is the carboxyl group. So here we could find that whatever the compound that contains C, which is going to consider to be an organic acid. So here we'll find that carboxylic acid, they are found in nature in a lot of sources. So like the citric acid, which found in citrus fruits like lemon, tangerine, orange, and so on. Okay, and we vinegar also is considered to be as a carboxylic acid, and so on. What is important about the carboxylic acid, that when they are somehow weak dissociate in water. That means when they dissolve in water, they have a reversible reaction, as we remember the equilibrium reaction. That means it's not completely break down. Some of it's gonna break down and releasing the hydrogen proton, which is responsible for the acidic medium characteristic. And the other, okay, they will bond together to form the acidic acid one more time. So that's why we consider they are weak acids, because they are not completely ionized, but they are partially ionized. Okay, so that means the carboxylic acids, or the organic acids, somehow they are weak compared to the inorganic acids like sulfuric acid, for example, or nitric acid. Okay, because nitric acid and sulfuric acid, they could dissociate, or they could ionize completely in water. Okay, and producing more number of or more concentration of hydrogen protons compared to this kind of acids. Okay, so actually these acids are important and they are already forming inside different living organisms. Okay, so as we said, they could find in some plants, fruits. Okay, and also some of them they already found inside the animal tissue. Like once you make an intense exercise and in absence of oxygen, your body is going to run out the fermentation process, producing the lactic acid inside your muscles. Okay, so here like this we have a lot of acids. Okay, some of these acids actually we use it in our daily life like vinegar. Some of them is already are produced by some microorganisms. Okay, like some kinds of bacteria like the lactic acid bacteria. Okay, which is already we use it to making the yogurts and so on. So there are a huge variety of carboxylic acids in our daily life. The last kind of components, or the last like kind of compounds here, which are the esters. So what are esters? Actually they are esters, they are that organic compounds which have this functional group, which is the ester group. So what this group is COO. Okay, and as you can find here, this carbon is attached to alkyl group while the oxygen is attached to the other alkyl group. Okay, so as you can find here, any ester is produced from the esterification reaction, which is a reaction between alcohol, organic alcohol. So like for example, the organic alcohol is ROH, and here, okay, and carboxylic acid, that means COOH, that the acid RCOOH. So what happened in this reaction? Just we are gonna just get water out, or producing water in which the hydrogen of the alcohol will be lost with that. So removing this by water, getting water out. So then we are just connect the rest. Okay, so it will be ROCOOR, the same like this one. Okay, so ester is produced by removing water from both organic acid and organic alcohol. Okay, and they are just, so in that case here, actually esters they are well known by the good smell they have. Okay, most of them actually they have a lot of the smells, so they are used in making perfumes and something like that. So here guys, that the different classes of the organic compounds. So we have alcohols, alkyl halides, and then ethers, ketones and aldehydes, acids and esters. Okay, and also amines. So any hard question to any one of these classes, guys, or something is not clear? Guys, any hard question here?
Thanks.
So like this, okay, we end our section here. Okay, so that you're supposed to study this part very well, and please answer the section review. Send your answers through the SMS mail. I'm gonna waiting for your homework. And next session, inshallah, we are just gonna discuss the questions together. So please, okay, try to study your lessons, and if you have any question or something is not clear, please ask. We still just have one lesson, okay, in that chapter, and like this, we're gonna end our material. So try to gather, okay, your information. If you still have something is missed, is not clear, try to save the time and send me your questions. So any question before we end our meeting, guys?
Thank you.
Okay, thank you. Goodbye.